Hi everyone, welcome to the lecture number 16. So basically, before starting each lecture, I'm very excited. And as a good teacher, I have two responsibilities. One is to give you the best quality lectures. Second responsibility is to make sure that you all are following these lectures with consistency. Okay, so I figured out that many of you started the series, but few of you lost the track, few of you lost the motivation to continue. So I took a poll on my Telegram. Okay, you will find the link in the description. So I took a poll on my Telegram, and there I figured out that the reason that many of you are basically getting demotivated is you skip one lecture, and that leads to a domino effect. If you leave the lecture number 10, you will think that okay, lecture number 11 I will not be able to understand because I don't know lecture number 10. So you will skip the lecture number 11 as well, and this domino effect leaves a very bad impact, and your entire preparation strategy will be changed. Then you will try to find some other resource, then you will try to start from the beginning, and it will keep on happening again and again, and you will not be able to prepare for the placements. Okay, placements are near and it is not difficult to prepare for it. The only thing is you have to show your dedication, you have to show your consistency. That's it. And let's say if you broke that consistency, what you can do is you can find a free slot, maybe on Friday, Saturday, on weekends. Find a free slot, sit for a couple of hours, try to complete all the pending lectures, try to watch all the pending lectures, try to code them. Okay, if you are able to do two at a time, do two at a time, no issues. If you are able to do single lecture in a single sitting, do a single lecture, but come back on track again, then only we will succeed, right? Okay, great. So this is the lecture number 16 and I'm excited to start with this. It's going to teach us a lot of things, and pretty soon we are going to start with dynamic programming as well. So it will give us a very good idea that basically we are learning dynamic programming already. So we have solved a couple of questions using recursion, right? We are learning dynamic programming. You just have to make like a 2-line of change and that solution will get converted into a DP solution, dynamic programming solution. There's nothing. Okay. Alright, so this is a very good question. Let us start with this question. So partition to k equal subsets is the name of this question. We will be given an array. Meanwhile, let me take an example as well. So we will be given an array. Let's say the elements of the array are 4, 3, 1, 3, 4, 3, 1, 2. These are the elements 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. So you have to split these elements into k subsets. Okay, k subsets, or we can say k different buckets, and the summation of each bucket or each subset should be equal. Okay, they all should be equal. All right. So one very intuitive thing that we can figure out is the summation of each bucket is going to be what? What will be the summation of each bucket? That will be the total summation, total summation divided by k, right? So the total summation here is 7, 8, 11, 11 plus 4, 15, 15 plus 5, 20, 21. So total summation is 21 divided by k. Let's say k here is equal to 3. So we have to divide them into 3 different buckets, right? So k is 3. So 21 divided by 3. So 7. 7 is going to be the summation of each bucket. Okay. So we just have to tell whether, So we just have to tell whether we can divide this array into k different buckets or k different subsets such that the summation of each subset is 7. That's what we need to figure out. And accordingly we have to tell true or false. If we are able to do it, we can say true. If we are not able to do it, we can say false. Okay. Now one obvious thought is, let's say if this sum is not divisible by k, let's say the sum is coming out to be 22 and we have to divide it into 3 different buckets of same sum. We will not be able to do it, right? 22 is not divisible by 3. We will not be able to do it. In terms of coding, we can say that 22 modulo 3 is not equal to 0. That's why we will not be able to divide it into 3 different buckets of equal summation, right? So that is the first thing that we can think of. What else can we think of? So it might be a possibility that even if we have the summation divisible by this k, then also there might be a chance that we are not able to divide them. I will show you. Let me show you with the help of the example. So let's say we have this k as 3 only, k as 3, and the elements are, let's say the first element is 7 and the next element is 9. And the next element is, let's say 11. Not 11. 9 plus 10, 16, 16, let's say 4. So these are the elements. It is not divisible by, okay, let's say it is 5. So now the entire summation is 12. 12 plus 9 is 21, right? 12 plus 9 is 21. So the entire summation is 21, which is divisible by 3. But we will not be able to divide them into 3 different subsets which whose summation is same. We will not be able to divide them into 3 different subsets with the same summation. Okay, so this is the example of where we cannot divide. Now let us see the example where we can actually divide them. So here, okay, for this particular example, let us see if we can divide this into three different buckets of equal sizes. So the first bucket is going to contain 4, 3. Okay, the second bucket is going to contain 1, 3, 3. The third bucket is going to contain 4, 2, 1. Okay, first bucket is going to contain 4, 3. Second bucket is going to contain 1, 3, 3. Third bucket is going to contain 4, 1, 2. So we are able to divide them into 3 different buckets of same summation. That's what we need to figure out in this question. Okay, so let us start solving this. So let us see if at all we can solve this question using recursion. Alright, so we have n number of elements, right? And k number of buckets. So one solution is, I can think in terms of recursion. I can say that each element is having k choices, right? Each element is having k choices. It can either go to the bucket number 1, bucket number 2, bucket number 3, and so on till bucket number k, right? It can go to any of these buckets. Similarly, the second element is going to have k choices, and so on. So this is one of the solutions which I can think of. Let me draw the recursion tree for the same. Let us start with I is equal to 0. So this is the first element. Basically, this first element is going to have k choices, and here let us say k is equal to, let us just say k is equal to 5 here, for example. So it's going to have 5 choices. It can either go to the bucket number 1, okay, or it can go to the bucket number 2, or it can go to the bucket number 3, or to the bucket 4, or to the bucket 5. Okay, 5 choices. All right, now here I is going to become 1. So basically we are talking about the second element. Now the second element also is going to have these 5 choices. It can go to the bucket number 1, or to the bucket number 2, or to the bucket number 3, or to the bucket number 4, or to the bucket number 5. Okay, similarly here also 5 choices. So it is just like the recursion tree which we have seen in the past, where we used to have only 2 children or 3 children. Here we are having 5 children at each level. So we are starting with one node, then we are going to 5 different nodes, then from here we are again going to 5 different nodes, from here also 5 different nodes, and from here also 5 different nodes. So basically here we have 1, here we have 5, here we have 25, and here we are going to have 25, 25, 125, and so on. So it is again a geometric progression. You can imagine how huge the tree is going to be. The tree is going to be very huge. Okay, so it is a geometric progression which depends upon k, where the common ratio is k. Here k was equal to 5, so the common ratio was 5, but in general it is k. So the common ratio here is k. 1, k, k square, and so on. If you try to find out the summation of this GP, so what is the summation of the GP? Summation of GP is a multiplied by r raised to the, a multiplied by r raised to the power n minus 1 divided by r minus 1. Okay, here r is the common ratio, n is the number of terms, a is the first term is 1. So 1 multiplied by r is k, right? Common ratio is k raised to the power n minus 1 divided by k minus 1, which is pretty much, if we just approximate this, it is going to be k raised to the power n. It is just the approximation. You can ignore this term. In front of this, it is very less, so you can ignore it. So k raised to the power n number of terms, that is going to be the time complexity, which is very bad, k raised to the power n. And you can imagine the height of the tree as well. Height of the tree will depend upon this number of elements in the array, right? It will be n. Height of the tree will be n. So the space complexity big O of n, time complexity k raised to the power n. Pretty bad. Okay, we will not quote the solution. It is not a good solution. We will try to imagine some other solution, which is going to be a little tricky, not so tricky, but if you will pay 100% of your attention, you will be able to understand it. So pay focus. All right, so what am I going to do now is, so basically I will not give each element the choice to go in any of the given buckets. Rather, I will go bucket wise. I will say, okay, right now I am filling this particular bucket, the first bucket. Right now I'm filling the only first bucket. All right. Now I will ask each element if you want to go in this or not. Then to the second element, if you want to go in this or not. Then to the third element, if you want to go in this or not. Then to the fourth, if you want to go in this or not. And this way I will keep asking for each of the elements. All right. Okay. So that's what I'm going to do, and things will become much more clear if we, okay, let me draw the recursion tree for this first. Let me draw the recursion tree. All right. So let's say we start with I is equal to 0. Okay. And we are filling the bucket number 1. Initially we are starting with the bucket number 1 only. Okay. So let's start filling the bucket number 1. It is going to have two choices only. First choice, whether to be considered in this bucket, okay, or to be not considered in this bucket. All right. So if it is considered in this bucket, let me take the example, same example, 4 3 1 3 4 3 1 2. So we are talking about this element, right? So the summation of the bucket will become 4. Here the summation of the bucket will remain 0. Okay. We are talking about the first bucket only. Then coming to this element, I is equal to 1. Coming to this element 3, it is also having two choices, either to be considered or to be skipped. So if it is considered, the summation will become 7. If it is skipped, it will remain 4. And here if it is considered, it will become 3. If it is skipped, it will remain 0. I is equal to 2 here. Then again, when I is equal to 2, we are talking about this particular one. If we consider this, it will become 8. From 7 it will become 8. If we not consider it, it will remain 7. Here also it will become 5, or it will remain 4. Here also it will become 4, or it will remain 3. Here also it will become 1, or it will remain 0. Okay. And we have already seen that the summation of each bucket in this particular example, okay, in this particular example, k was given as 3 and total summation is 21. So the summation of each individual bucket is 7. It should be 7. So we figured out that, yeah, we are able to get 7. And how are we able to get 7? We are considering the first element, which is 4. We are also considering the second element, which is 3. So 4 comma 3 is going to give us one of that possible bucket. So we will stop here. Okay, we will stop, and then we will try to create another bucket. We will try to create another bucket. Okay, and so on. This is how we are going to explore all the possible buckets, whether we can create all the possible buckets or not. So we will go bucket wise here. Okay, things will become much more clear once we start coding this. All right, so before the coding part, let me also explain the space and time complexities over here. So we basically figured out the answer for the first bucket. We have to do the same kind of thing for all the remaining buckets as well. Okay, so we will have to go to all the elements again, right? It might be possible that we have skipped few of the elements, then we have selected few of the elements. We will have to keep track, obviously, that which element we have selected, which element we have not selected. We will be keeping track of that. But again, we will have to start from the beginning only. It might be possible that I skipped the index 0. So I will have to start from the beginning only when I'm constructing the second bucket. I will have to start from the index 0. All right. And to whichever index I will go, I will first see whether in the bucket 1 I have already picked this one or not. If I have already picked this one, I will skip it. I will skip. Okay. If I have not picked this one, then I will have a chance to pick. Okay, so that's what we are going to see in the code, but we will have to traverse the entire array again for the second bucket also. So this kind of tree, the similar kind of tree will be constructed. A similar kind of tree will be constructed below this. Okay, below 7, a similar kind of tree will be constructed. So we can say that if n is the height of one tree, there are going to be k number of such trees created. So in the worst case, k into n is going to be the height of the entire tree. Height of the entire tree. So this will be the space complexity, right? This will be the space complexity, the height of the entire stack. All right. Now the total terms, the total number of nodes in the tree are going to be 2 raised to the power this. Okay, 2 raised to the power this. All right. So this is going to be the time complexity, 2 raised to the power k into n, and the space complexity is going to be k into n. All right. So this is the entire recursion tree. Now you will actually see how we can code this. Okay, the coding part is going to be very simple. All right, so we have to create a function which will return us true or false. I will name this as help. I will start with I. This is the ith number. This is the ith element which I am currently standing on. Then I have the bucket number, right? B-U-C-K-E-T, bucket number. Then I have the bucket sum, the sum of the current bucket. Then I have the required sum. This is the required sum of the each bucket. Required sum. int k, this k denotes the total number of buckets, right? Total number of buckets. Then we will have this vector of int nums. Obviously we will have this. Then we will also have to keep a vector which is going to tell that this particular element we have already selected for the previous buckets. Okay, so we will have to keep a vector for that. Vector of int already picked. All right, so this is what we are going to have. Oh, okay. Now this is the entire function. Now let us start writing this. So we are talking about the current bucket. We are talking about the current bucket, and we are basically checking whether the ith element is going to be a part of this bucket or not. So first of all, just check that if this particular ith element has been already picked up by some previous bucket. So already picked of I. If it is equal to 1, it means that it is already picked up in the past. So if it is already picked up in the past, you can simply not pick it up now. Okay, it is already picked in the past. So you will simply return help of, go to the next element. Okay, there's no point wasting time on this element. Go to the next element because this element was already picked. Then the bucket number is going to remain same, and bucket sum is going to remain same because we are not changing anything. We are not basically considering this ith element. Required sum will remain same, then k, then nums, then already picked. All right, if this element was already picked. If this element was not already picked, we have two choices. Okay, we have two choices. One choice is to pick it up. To pick. So let us pick this element. If we want to pick this element, our bucket sum is going to increase. Bucket sum plus equal to the current element, this nums of I. And because we are picking up this element, right, that's why this already picked of I will become 1. We have already picked it up. Okay, so we increase the summation. We picked up this element. Now option 1, boolean, bool option 1 is to call the help function. Help I plus 1, go to the next element, bucket sum, then bucket num. First is bucket num. First we have bucket num, then bucket sum, then required sum, then k, then nums, and then already picked. Done. So this is the first option. Second option is to skip the ith element. If I want to skip the ith element, first of all I should undo the changes which I am doing in the line number 7 and 8. I should undo these changes. So let me do some minus equal to nums of I, and already picked this is equal to 0 now. This should be equal to 0. Okay, so undo these changes. Now option 2. So bool option 2 is equal to help of, go to the next element, bucket num, bucket sum, required sum, k. Everything is going to remain same because we already made the changes over here. Okay, we already skipped this element. Now these are the two options. The one option number 1, then second option number 2. We have these two options. So basically we are just asking recursion to bring rest of the answer, right? We are just asking recursion to check for rest of the answer. In the option number 1, I am saying that okay, let me put the ith element in the current bucket. Remaining task you do. Okay, it's asking recursion to do the remaining task, and now recursion will tell, okay, from the choice that you made of picking the ith element, the answer is coming out to be true or false. Okay, this is what the recursion is going to tell, and we are going to save it in the option. Okay, recursion is going to say, all right, I'm going to do the rest of the task now, and from the choice that you made over here of picking the ith element in the current bucket, this is giving me the answer as true or false. That true or false is going to be saved in the option number 1. Then Again, option number 2 is to skip this element. Okay, so we skip this element and we ask recursion to do rest of the task. Now recursion will do rest of the task and it will bring us whether by not picking this element or skipping this element you are getting the answer or not getting the answer, true or false. This is the second option. All right, and in any of the case, so let's say if by picking this element we are getting a true answer, that means yes, we can construct all the buckets of sum of the given sum, of the required sum, right? And if both these option 1 and option 2, if both of them are false, like even after picking this element, recursion is saying no, in future also you cannot basically make those buckets. Okay, in the option number 2 also recursion is saying same, even if you skip this element you will not be able to generate all those k number of buckets in future, right? So if both of them are false, obviously our answer is false, right? Even after picking, recursion is saying that you cannot make k such buckets. Okay, even after skipping, the recursion is saying you cannot make k such buckets. Both of them are false, then return false. If any of them is true, if any of these is true, you have to return true. So return the option 1 or option 2. So if any of this is true, we are going to return true. If both of them are false, we are going to return false. Okay, we have two options, to pick this element or to not pick this element. Okay, once we pick this element and then ask recursion, okay, can you get the answer now? It will be saved in the option number 1. Recursion will say yes or no accordingly. In the next time we will skip this element and we will ask recursion, can you find the answer now? Recursion will say yes or no, and that yes or no will be saved in the option number 2. Okay, if both of them are true, basically it means that recursion is saying if you pick this element, then also I will get the answer. If you not pick this element, then also I will get the answer. Then obviously you will get the answer, right? You will return true. If any of this is true, then also you will get the answer. If any of this choice is true, you will get the answer. If both of them are wrong, okay, basically which means that even after picking, you are not able to generate those k buckets. Even after skipping, you are not able to generate those k buckets. That's why return false. So this OR is going to handle this. If both are true, return true. If any of this is true, return true. If if both of them are false, then only return false. Okay, done. So we are done with this. Else part is done. Okay, so yeah, great. Now talking about the base conditions. One of the base condition would be, let's say if for the current bucket the bucket sum, if for the current bucket the bucket sum is equal to the required sum, then what are you going to do? What are you going to do in this case? In this case, it is very simple. You basically constructed a bucket. Now try to find out the next bucket. Okay, now try to find out the next bucket. So simply return help of start from 0, because we are constructing the next bucket, right? Let's say we have filled the first bucket, we will be constructing the second bucket, right? And for that we will have to start from the beginning. We will have to go to all the elements one by one, because it might be possible that I have skipped few of the elements in the past. Okay, so you have to check again which all elements are left. You have to start from the beginning. So start from I is equal to 0. Then bucket number will increase. Bucket number will be bucket number plus 1. It will be incremented by 1. Bucket sum will again start from 0, because we are starting with a fresh new bucket. So it will be 0. Then required sum will remain same. Then k will remain same because we don't have to change it. Then nums, then already picked. Okay, all these things are going to remain same. Done. That's what we have to do. If the bucket sum is equal to the required sum. Just in case if it is greater, if bucket sum, if it is greater than the required sum, then what will happen? We are going in the wrong direction basically. We are constructing a bucket, the current bucket, and we exceeded the summation. We exceeded the required summation. Return false. You are coming in the wrong direction. Okay. But just in case if this I becomes greater than equal to nums.size, then what will happen? Again we are coming in the wrong direction. Return false. Okay. There's one more thing, one more very important base condition. What if this bucket number, so basically you started with the bucket number 1, 2, 3, 4 and so on. If this bucket number is equal to k plus 1, so basically you filled the bucket 1, 2, 3, 4, 5, 6 till k, you filled the bucket k, and now your bucket number is k plus 1. Basically means that you filled all the buckets and then now return true. From here return true. Okay. So I think this is it. Let me try to run this. First of all, I will have to create a vector of int. Let me just put the laptop on charge, otherwise I will have to re-record the entire thing again. So let me put it on charge. All right, yeah, so we can continue. So first of all, we are starting with already picked. Already picked. This is going to be of size n and everything will be 0 initially. Then what else do we have? I think that's it. Yeah, so let us call this function help. This function help will be taking I will start from 0, bucket number will start from 1, bucket sum will be 0 initially, required sum, okay, required sum we need to calculate, required sum we will calculate, then after this k, then nums, then already picked. And whatever this help is returning, we have to return that, so return this, okay. Now int sum, this is the total summation of the array, so I am going to take it using a for loop. For int I is equal to 0, I smaller than n, I plus plus, sum plus equal to nums of I. Done. So this is the entire summation. Now the required summation will be, first of all, we will check that whether this sum can be splitted over k number of buckets. So if it at all it is divisible by k. So if this sum modulo this k, if it is not equal to 0, basically it means that if it is not divisible by k, then return false from here itself. Okay, otherwise int required sum is equal to the total sum divided by k. This is the required sum of each bucket. Okay, let us try to run this. If there are any bugs, we will resolve. Already picked was not declared. Already picked was not declared over here. Already picked. All right, we are getting a correct answer. Let me try to submit this and you will see something very astonishing over here. It is going to give us a TLE, time limit exceeded. Although this solution is correct and interviewer will be happy if you give this solution, but to make this solution accepted, you have to know a bit about dynamic programming. Okay, a bit about dynamic programming. So it is very simple. We just have to save few states. Few states are repeating again and again. So it could be the combination of this I and this bucket and this sum. This is repeating again and again. We just have to do a memoization. That is just a 2-line of change and it will give us a correct answer. But wait for that. Soon we will start dynamic programming and you will see that with the change of just 2 lines, you will be able to get this solution accepted. Okay. So wait till then. Although if the constraints were low, this would have been like accepted with this solution as well. This is the correct solution. This is what you need to know in terms of building a recursive solution. This is what you need to know. But we will convert this soon into a dynamic programming solution. Okay. So just wait for that. Stay tuned. Let us meet in the next episode. Bye bye. Take care.